Hi, second graders. Miss Uriel here from Citizenship Academy, and we are on Module 8, Lesson 8 today. Make sure that you have something to write with, because we're going to start off with some fluency and an application problem. All right, so Lesson 8 is all about, yesterday we talked about splitting shapes into halves, thirds, and fourths. Today we're going to talk about the different shapes that make up a larger shape. So for example, when we have a rhombus, two small triangles will fit in that rhombus. And we'll go through it like that. All right, first we're going to do something we did a couple of lessons ago. I'm going to give you a number. We're going to take 10 tens out of that number, and what I want you to tell me is how many hundreds we might need, how many tens there are going to be, and how many ones there are going to be. So let's start with the number 121. How many tens, if we take 10 tens, so no hundreds, 10 tens out, how many tens are going to be in this number plus how many ones? So as you know, 10 tens equals 100. We have the number 121. So we have the 100 pulled out. Now I'm noticing in our tens place we have two more tens. So we're going to have to add that to our 10 tens. 10 tens plus 2 tens is 12 tens, and then we have that 1 1. You guys remember this, right? We got this. All right. Now this one, same thing. We're going to pull the 10 tens out, so that's going to equal 100. However, we're still going to need some hundreds and some ones to finish this number out. So how many hundreds and how many ones will we have when we take those 10 tens out? Good. So 10 tens equals 100, and we need 200, so we're going to need one more 100, plus our 10 tens gives us 200, and then we need our 4 extra ones, 204. Nice job. All right, this one's similar to this one, but check your tens place. So remember, we're going to pull our 10 tens out, and then how many hundreds will we have? Be careful with your tens. You're going to have more than 10 tens, and then how many ones will we have? Very, very good. So we know 10 tens equals 100. So we're going to need another 100 to get to 200. Now, we have 10 tens already out, but we need to add that other 2 tens that are here, and that's going to give us 12 tens. And then we got to add in our extra 4 ones. We get 224. All right, try this one. How many tens? How many ones? Yeah, this one's easy. 10 tens, 8 ones. This one's a little bit trickier, but you can do it. We're pulling the 10 tens out, remember. So if we pull 10 tens out, we have 100. How many more hundreds do we need? And then how many ones will we have? Very, very good. So if we pull the 10 tens out, that's going to be 100. 900 take away 100. We're still going to need 8 more hundreds. And then we get our 10 tens, so that equals 900. We don't have any other tens. And then let's add in our 8 ones. We got it. Good job. All right, use what you know here to help you with this one. Just be careful with your tens place. This one, we didn't have to add in any extra tens. Make sure you look at your tens place for this one. Tell me how many hundreds, how many tens if we pull those 10 tens out, and then how many ones. Good. So the 10 tens is going to be 100. So we already have 100. If we take 100 away from there, we still need 8 hundreds. Now, we have our 10 tens, plus in our tens place, we have 6 more tens. So that's going to be 16 tens, and then we just have our 8 ones. Easy peasy. You guys got this. All right. Take out your paper, pencil, whiteboard, marker, whatever you have with you. We are going to practice our subtraction again. You guys did really well with that yesterday, so we're going to practice some more. Again, solve it how you want. You can do vertical method, place value chart, number bonds, whatever you do. I want you to do this on your own, and then we'll go over it. Whoop. So I'm going to do 123 minus 47, and then I want you to solve. All right, here we go. So we have 100, 2 tens, 3 ones, minus 4 tens, 7 ones. When we do this, we can't take 7 from 3, so I'm going to take some tens. 1, add my tens over here. 13 minus 7. Now we can't take 1 from 4, so we're going to take some hundreds, move them over. 11 minus 4 gives us 7, and we end up with 76. Nice. All right, try this one on your own. 132 minus 59. It's going to be 100, 3 tens, 2 ones, minus 5 tens, 9 ones. Go ahead and pause and solve in the way that works best for you. All right, let's go over it together. So we know that we cannot take 9 from 2, so we're going to borrow 10 ones, take a 10 away, add them into here. 12 ones minus 9 ones is going to give us 3 ones. We cannot subtract 5 tens from 2 tens, so we're going to borrow from our hundreds. Move 10 tens over. 12 minus 5 is going to give us 73. Awesome job. All right, let's do another one. Again, solve it in the way that works best for you. 231 minus 65. 2 hundreds, 3 tens, 1 1, minus 6 tens, 5 ones. All right, let's try it. Again, we can't take 5 from 1, so we're going to borrow from our tens place. Add our 10 ones over here to our 1 1. We get 11 ones. 11 minus 5 gives us 6. We cannot subtract 6 tens from 2 tens, so we're going to borrow over here. Add our 10 tens over. 12 minus 6 is 6. And then our hundreds, we just bring down our 1. We get 166. Nice job. All right. 300 minus 25. Solve in the way that works best for you. It's going to be 3 hundreds, 0 tens, 0 ones, minus 2 tens, 5 ones. So pause and solve. Come back when you're ready to go over it. All right, here we go. So we have 2 zeros here, so I'm going to have to start over in my hundreds place. I'm going to take 10 tens and move them over. But I know that I need the 10 over here, so I'm just going to write a 9 already because I know I'm going to have to move it over again. 10 minus 5 is 5. 9 minus 2 is 7. 100 stay the same. We get 275. Awesome. All right, let's get into our application problem. Students were making larger shapes out of triangles and squares. They put away all 72 triangles. There were still 48 squares on the carpet. How many triangles and squares were on the carpet when they started? So, they're making shapes out of triangles and squares. We have triangles and squares all over the carpet. They put away the 72 triangles, so the triangles are gone, but they put away 72 of them. So I'm going to write that number down. There are still 48 squares on the carpet, so they still needed to pick up those 48 squares. What we want to know is how many they had all together when they started. The word all together were on the carpet when they started. All together means that we are going to add. All right? So use whatever strategy works for you. I would like you to add your 2 parts to come up with your whole to figure out how many triangles and squares were on the carpet when they started. Again, pause and take as long as you need and come back when you're ready. Got it? So, when we do this, there's a bunch of different ways to do it. What I'm going to do is number bond way, because I know we need 2 more over here. I'm going to add 50 plus 70 plus 2. Oh, 50 plus 70. My goodness. And I'm going to get 120. So they had 120 shapes on the carpet when they started. Nice job. Okay, so what we're going to do today is we're going to talk about the different shapes we've been identifying, and we're going to talk about how we can cover the shape with different smaller shapes. So if you look at this rhombus here, you see that line down the middle. So we have 2 halves of our rhombus. What shape, what pattern block could we use to cover up half of the rhombus? So look at this half here. What shape could we use? A triangle. Very, very good. All right. Let's try this one. So here's our hexagon. We cut the hexagon in half, so now we have two halves that are the same size. What shape could we use to cover half of the hexagon? Two of these would equal one whole hexagon. A trapezoid, very, very good. All right, try this one. Now we're cutting our hexagon into thirds, 3 equal parts, 3 equal shapes. What shape could we use to cover the thirds of the hexagon? All 3 of these shapes are the same. What shape would we use? A rhombus, awesome job. All right, now we're gonna break our trapezoid into thirds. Our trapezoid is now into 3 equal parts, into thirds. What shape could we use to break the trapezoid down into 3 equal parts? Triangle, awesome work. Now we're going to take one large square and we're going to break it into fourths. 1, 2, 3, 4, all equal parts. Those are fourths. What shapes are we using to break the big square into fourths? Smaller squares, right? Each smaller square is 1/4 of the whole square. Say that with me. 1/4 of the whole square. See how this one part is colored in? It is 1 out of 4 sections. 1/4 colored in. Now we're going to take 2 squares. Now 2/4 are colored in. So we have 2 colored in. That's 2 of the 4 are colored in. 2/4 colored in. What is that the same as? Think about what is colored in and what is not colored in. What is this the same as? 2/4 is the same as 1/2. You see that? The part that's shaded in is the same size as the part that's not shaded in. So 2/4 is equal to 1/2. Pretty cool, right? So if we color in one more fourth, one more small square, how many squares are colored in now? How many fourths? 3/4. If we color in one more, we get 4/4, and that's equal to 1 whole. Awesome. We're going to skip that one for now because I'm going to show you your exit ticket. What you're going to do is what we just went over. I want you to cut these shapes in halves. This one's going to be in thirds. This one's going to be in thirds, and this one's going to be in sixths. This will be a challenge problem. Tell me what shape you would use if you cut this shape in half. So we did this one already. If you cut this shape in half, you're going to have 2 triangles. And you'll go through each of the shapes telling me what shape you would have by dividing that shape into smaller pieces. And that's it for today.